Hi, and welcome to Mike Likes Robots, where we share knowledge to accelerate robotics. And today, I'm doing day 6 of the Advent of Code in Rust. So today's challenge is called Guard Gallivant, and I haven't read through it yet, so I'll do that now and cut to when I'm finished and I can explain the puzzle. Okay, this one is pretty simple to understand and probably going to be a bit harder to code, but it should be fun to have an attempt. So the puzzle gives you a grid of characters, dot being an empty space, hash being an obstacle, and an arrow representing a guard, which is facing in a particular direction. Now the rules are that the guard will keep traveling in the direction they're facing until they reach an obstacle, at which point they'll turn right 90 degrees and start moving towards the next obstacle. From this, you can figure out a path that the guard will take. And once you've got the path figured out, you can count how many positions the guard visits while traveling that path, and that is the result of the puzzle. So I think it's pretty easy to understand, so let's start coding it. I'm going to start by creating a new project. And I put that in the wrong folder. Now I'm going to cd in and open it up in code. This is just the standard project setup that we've done every day for the past few days. And just like normal, I'm going to create a puzzle, test.text, paste it in here. And then this is another case where it's a bit more tricky to create reasonable sized unit tests. It is possible, but I'm not sure it would help me complete the puzzle as quickly as just writing the software. So in this case, I'm going to skip making unit tests. I'm just going to go straight into parsing the puzzle input. So we're going to call the struct we're using a patrol path. Patrol path grid's a terrible name. Surely I can do better than that. It's a lab. So we'll call it a guarded lab. Okay, which will contain a grid, which will be a vector of. We could do car while we define the structure, but I think this will become. In fact, we might find an easier solution for this is to not save every character in a grid and check whether it's empty or not, but instead only save the obstacles. So I'm going to try doing that. That will be a hash map. It will be a point, Actually, it doesn't need to be a hash map, it just needs to be a hash set. And then we use that instead. And then it will contain points. Now, points we did use on day 3, I think it was. But that's in another file, so we could copy it over. But what I'm going to try and do, and I haven't done this in any advent of code yet, but I know how it works, is to move the point and direction classes from day 3 into their own crate, which will be accessible from any advent of code project. So I'm going to go up, I'm going to create a new project, which I'm just going to call util. And then I'll open that in a new window. Now I've immediately made a mistake, which is easily correctable, but I want to show that there's different ways of initializing the projects. We can do cargo new util --lib will, which will initialize it as a library instead. That means that we don't expect there to be a main function inside it. It doesn't run anything. It just provides utilities for other classes to be able to use. Let's take a look at that, and here we are. Now we are going to copy from day 3, source. We had point, which is not auto-completing. Because it's not from day 3. It's from day 4. Okay. We can copy point, we can copy direction. And at this point, all I want to do in my library is pub mod direction and pub mod point. What that will do is compile. Oh, we're not allowed strum. Strum wasn't doing much for us anyway, so I'm actually just going to take that dependency out. I'm going to copy and paste this vector and fill in the missing enum values. Okay, so that's the point, the direction structure from before, or enum, and also the point enum from before, which just declares a point with anonymous fields that are able to add together. So we can make this more complex as we need over the course of Advent of Code. So in this case, I'm going to cargo build it, which I don't need to do. Because if I take a dependency on it, which I don't remember off the top of my head how to do, I'll go local crate. Here it is. Ooh, or the equivalent toml. I think I'd prefer this one. So we'll have util and util. So at this point in my main, I should be able to use util point. And that's it. I've now got access to the same point structure that I had in day 4. Okay, so our grid is not really a grid. It's actually the obstacles. And we also have a guard start. And this will be a single point but it also needs to have a direction encoded. So for that, I'm going to create another structure which is going to contain that information. So this will be a facing point, or it's not a vector because it doesn't have a magnitude. So that will do. So this will have a pos point and a dir direction. Okay, so that's our guarded lab structure. Now I'm going to implement from Strua for guarded lab, same as the other exercises. Type error, I'm going to create a temporary structure, and I'll switch it to anyhow if I need it. I'm actually going to just create a couple of very quick helper functions to create new versions of these structs. Actually, this one doesn't need it because round brackets, so that's as easy as it gets. And then the direction, I'll just put direction up. That's a bit nicer. Now, I actually realized that I also need a width and a height for this. So I'm going to save those, and that's so that during my algorithm I can check if I've gone off the edge. So the lower bounds will be 0, 0, and the upper bounds will be width and height. So at that point I need height 0 and width 0. Okay. Can actually create a fairly simple unit test to check these, so I will do that. Mod tests, use super, test function test parse, okay. Now my string is going to be, I want at least an obstacle, empty obstacle, new line, a guard, empty obstacle, new line, empty obstacle, empty. Okay. Expected obstacles. In fact, I'll check that it can handle a non-square grid by removing that last line. Expected obstacles is let obs, mute obs is hash set new. Then I'm going to insert, and that's 0, 0, although I need to wrap it in a point. And then I need another one at, it's 2 over, so it's the 0th row, second column. And then another one on 1, 2. Then I need to return obs from that. Then our expected guard will be a facing point where the position is 1, 0. And our direction is facing right. Expected height is 2, and expected width is 3. Now we can actually parse the text that I've created at the top there. And I can check that the lab.guard start is the same as expected guard. I can check the width is the same as the expected width, and the height is the expected height. And finally, this will be a bit more tricky. I can check that the obstacles, the expected obstacles. Now, I'm not surprised that obstacles is unhappy. I am surprised that guard start is unhappy. Oh yeah, because that's a facing point. Yeah, that makes sense. Okay, let's get rid of these compile errors. So we need a few traits on the point class to be able to do all of this. We need to be able to hash it. We need to be able to compare it with equality. And then down here, we also need the equality. And here, we'll be able to derive equality from a hash set as long as point knows how to be compared. So basically, we just need point to have hash and equality implemented. Let's do that. And very simply, what we do is hash derive partial equality, equality, and hash. At that point, facing point also needs to be derive partial equality and equality. But that's not allowed because direction doesn't have those things. And that's easily done again. We can derive equality and partial equality. Now, I think that's okay, and it's only unhappy because changes occurred in another crate, and it doesn't know to check for those changes. So I'm going to cargo run, and we're able to run, but we're not using any of this code, so maybe that's not a fair assessment. Okay, we're still getting compilation errors. Hash set requires point to have debug as well. As does facing point. As does guarded lab error. Okay, so a few things we just need to derive debug on so that we can print them out. Debug. I'm going to copy this and put it here. I'm going to add debug to the things to derive here, and also to point. Okay, it compiled correctly. And our test does fail. So this is right, we just need Rust Analyzer to catch up, basically. I think if I just make a change, then it'll understand that it needs to refresh. So we're now, yeah, we have a test to make sure that the grid is being parsed correctly. So let's actually implement that logic. So we want to take all the characters, but as we go, we want to keep track of the index. So I'm going to use for row index row in s.lines.enumerate. I think this needs to be wrapped in brackets, so it's a tuple. Then for call index cell in row.iter row.cars.enumerate. Okay, now we can switch on the cell. I'm sorry, match on the cell. Now, if we're getting a hash, then we need to store that as an obstacle. So for that, I need a mutable hash set that I can update over the course of the loop. Obstacles.push or inserts. It will be a point containing the row index and the column index. If it is hat, then we will store it in the guard variable. However, Rust doesn't have a nil or a null. So what I'm going to do is define it as an option of a facing point, which is initially defined as none. Now guard can become sum of facing point, which contains pos of point, row index, column index, and a direction of up. Let's save this and format. And it doesn't like this because this is returning. I need to put a semicolon or a comma. No, semicolon is right. So why is it now complaining? It's because row index and column index are usize, and point hasn't defined as I32. So let's redefine them. And to prevent doing this logic over and over, I'm just going to convert it at the top and assume that Rust will optimize it out if it's not needed for a match statement. If not, it's fine. It's really a very minor operation to perform, and it makes the code more readable. Okay, at that point, our pos becomes P, and we're still upset. We're upset because insert will return a bool. So I don't know if I can just do a semicolon like this. That does work. I'm not happy with how ugly that is. I guess another thing that I can do is just save it to an anonymous variable that I don't return. Either way, it's not great, but that's fine. At this point, we can repeat this logic for the other directions. So I'm going to take this and repeat it. And I'm going to need the right-facing arrow to be right, the left-facing arrow to be left, down-facing arrow, which is a V, that will be down. Then I want a dot to be ignored because we don't have anything to do with it. So we're just going to continue, I guess, that thing. I think so. And then if we get anything else, that's an error. So at that point, we want to return an error, and it'll be a guarded lab error. And of course, we don't have any possibilities for this. So I am going to create a possibility, which is a parse error. Actually, this will be an unrecognized character. So if you want to see what it looks like when it gets an unrecognized character, by the way, this yeah, I can quickly show that. So let's just put a P in here and then run the test and see what the panic says. So it tried to call unwrap on an error value unrecognized character. So even the because I've defined a reasonable error name, I can now see what went wrong. I could also check for what kind of error it was and give a better message, but this is fine for my purposes. So I'm going to change that back now to a dot and then complete the rest of the parsing. So at this point, I've got obstacles and I've got my guard. What I don't have is the width and height. So I can define those pretty easily. The width is the I'm going to change this from S to puzzle. That's our standard puzzle. And then it will be puzzle.lines.first.length. That's not happy. Lines.count should work, but it's not the width, it's the height. So the width should be the first line. So I'm going to assume that I can do 0 here. No. Dot next. Is that allowed? It is allowed. But I need to call into iter. I don't really know why. But that doesn't work. What does it into iter do? A consuming iterator. All right, I'm not really clear why that needs to be into iter. I guess it's because it returns an option. And then into iter can consume even an option. Yeah, that's what this is saying. Because it's some string, it returns a vector with the string inside. And if it's empty, then into iter will give the 0 value back. So this will give me a count of 0 if the grid is empty because of into iter. And it couldn't have done it otherwise because next returns an option. So that's why. Okay, so at this point, I can now get rid of these zeros. My guard starts. I need to check whether I actually have a guard. So if not guard dot is sum, return error. And in this case, it will be a guarded lab error, but we're going to put a new one in, and it will be a guard not found error. Try guard is none. Yeah, that makes sense. That's just a linting warning. It would have done the same thing, but if there's a method for it, then I might as well use it. Okay, so if guard is none, then return guard not found. Otherwise, obstacles is already set. Actually, what I can do is let guard start equals match on guard. If it's some guard, return some G, return G. If it's none, then return error. That allows me to unpack the guard. And because I gave it the same name, I no longer need to give it a colon and then set it to something. So at that point, our parsing should be complete. If I run this test, it should pass. It fails. And that's because Why is that? Because I expected the width to be 3, and it's not giving me 3. Definitely ought to be. So I'm just going to print out the whole lab and see what's going on inside. Should have derived debug on it. Yep. So let's see what's inside. Width is 1, height is 2. Okay, so the logic to get the width out is not correct. Looks like the rest of it has passed correctly though. So it is only the width that's a problem. Let's take a look at that. I'm going to do this as a separate part of the for loop. It would have worked the other way. I'm not sure what I did wrong, but I just want to get this working. So we're iterating over rows and we're iterating over columns. So width should be the maximum of the column index width dot max column index plus 1. And then the same can go down to here for the height, but using the row index. Okay, now we don't need these. Let's check it. Passed. Okay. So that's pretty simple. It's just as it's going over the rows and inside the rows, the cells, it tracks the highest index that it encounters for each of the row and the height, which gives us the width and the height. Okay, so at this point, the puzzle is passed. We now just need to solve it. One useful method that I think I can use is on the direction. I think I can add a public function which is called write90. And self, it will return another direction. And then we're going to match on self. And then we basically just need to define it manually. So right goes up goes to right, up right goes to down right, right goes to down right goes to down left. We can actually just use this order. Okay, so right, down, left, left, up, left, up, and up, right. That should be that. I've defined it for the diagonals just to make it complete, although we are only dealing with up and down on this. Okay, so we've passed the puzzle. Now it's time to actually work on the solution. So let's start implementing on guarded lab. Function part A, which will take a reference to self and return the use size. And what this will do is just simulate the way the guard is traveling and then return the number of positions. So I'm going to keep a hash set of all the positions that the guard visits while they're traveling and then return the length of that hash set. But first, nope, that's fine. Let's go. Okay, so mute traveled is a new hash sets, and guard is a facing, actually I can just set it to self.guard start. Now, we want to keep running this as long as the guard is within bounds. So we're going to say function in bounds and self. And realistically, we want a point for this. So we're just going to take a reference to a point. It'll give me a bool. And I want it to be, the point can be I32. So we're going to have point.0 greater than 0 and point.1 is greater than 0 and point.0 is less than self dot. So 0 is the row index, which means the height. So I need to compare against the height. Point.1 therefore compares against the width. It's so easy to get this wrong, which is why I need to check it carefully. So height and width are saved as usize, so I need to switch those to I32. That's it. Okay, so I can actually just return travel.count. Or length, yes. So the reason this is a hash set is because if the guard visits the same point, but is facing a different direction, so it's not a loop, but it is traveling across a path it's already traveled across, I don't want to count that as another position that it's traveled. So that reason as well, it should be a hash set of points, which I'm going to define now so that I don't accidentally add a facing point, which is not what I want. Okay, so while self.inbounds, we're going to take our guard.pos, simulate the travel. So our next pos, we can also add the guard.pos immediately. Okay, so the next position, it depends if there's an obstacle or not. So because it's facing up, we can get the point for that and we can get the position for it. So it's going to be guard.pos plus guard.dir.toPoint. So if it's facing up, it will add 1. And if that is the case, then we need to check whether that point is allowed. If it is not allowed, then we need to turn 90. If self.obstacles.contains next pos, then guard becomes, it will be a new facing point where the position is guard.pos plus guard.dir.write 90. No, that's not true. It'll be the same position, but the direction will update. It'll be guard.dir.write 90. And then continue. That's our rotation logic, and that will work even if there's multiple obstacles because we're using the while loop and checking the bounds. However, if we get to this point, that means there is no obstacle in front. So now our guard can travel to the next position. So guard now becomes a facing point of pos, guard.pos plus dir. We don't do add, Although I think we can do that, but I've defined it as .add. And again, here it will be .add guard dot. Sorry, we've already calculated the next position. I just need to save it. And the dir is the same, guard.dir. Now we have a new position. We also need to save that into our traveled, which we have still as guard.pos. Now I think the logic there is actually complete. I just need to figure out compilation errors. So first we need to borrow this point. We also need to borrow here. We're borrowing a moved value, and we can't move out of self. So what we can do here actually is clone it. Actually, I think it's perfectly fine to define copy on point and on direction, and then derive it on guarded lab. So I'm going to define clone, and I'm going to define copy. And I can't do that because it's got points and facing points, so I also need to derive it on those. That'll be clone and copy. And we can't define copy because point and direction need it. That's fine. I can do it on there. Point, clone and copy. Better. And direction. Clone and copy. So at this point, I just need to refresh it. And that mostly looks fine. But I don't actually need it for the whole lab. Yeah, I don't know. That was a mistake putting it on that. Okay. And that is it. So we can create a test for this just to check that it gives the right output. It's the same that I would have just done with main. So test text, where let input is include string of puzzle test.text. We will parse it. Lab is guarded lab dot from str. Double colon from str input. And then assert equals lab dot part A. I need to unwrap it. Part A will be 41. And failed. It's giving me 42. And off by one error. I guess I'm adding the first point that is outside the bounds of the grid. So I could actually just return -1, but I'd rather do the more correct thing, which is to insert it as the first step. Now the reason that works is because if I insert at the end of the function, then it might be out of bounds and I just haven't checked it yet. Whereas if I insert it at the start of the function, it is guaranteed to be within bounds. Okay, so at this point, I can define puzzle is include string, puzzle test.text, let lab is guarded lab from str puzzle, and then we're going to expect a message. It could be different things that go wrong with it. So unable to parse guarded lab. And then we're going to print line part A will be lab.part A. That should be it. We run this, we'll get the correct answer printed out. And if I change test text to, I want to test the error values, see what it prints out. Unable to pass guarded lab, guard not found. So there you go, that's what it looks like. And in fact, if I remove the exclamation mark, it gives a better error message. All right, now I'm going to take the puzzle input and then run this. I need to update this point to input, not test. Okay, 4788. That's what I get. Let's check it. That's not the right answer. Your answer is too low. I'm going to do something silly and just check if... I wonder if I've done the bounds checking correctly. It's got to be equal. Greater than or equal to 0. Which does add 1 on, so... if I had just guessed added 1 on, I should check that the test still works. Okay, test, it does. Let's try submitting that. That's the right answer. So I'd guessed that I was off by 1, just as a guess, and I was right, but I went back and found out why I was off by 1. So that's a better result. Okay, I'm now going to read through part 2 and cut to once I've finished reading it. What we need to do is to figure out 6 places to, figure out how to insert one obstacle such that it causes the guard to go into a loop. And it doesn't have to just be up, right, down, left. It just has to be that it gets back to the starting position. Now, immediately with how I've coded this, I can see how to adapt it. I've got about 10 minutes, so I think I can do it in that. I may run a little bit over, but I think it's possible. And there's multiple positions where adding one obstacle will cause the guard to go into a loop. And we need to find how many variations there are. So I think that's very doable. So let's go into here. Let's create a part B, self, and return a usize. Now I will add a function to see if it gets into a loop. So test guard is in loop. And here my input so I want 3 lines, and I essentially just want a guard in the middle of walls that's going to face up. Oops, that should be that, and then dot, dot, except I want to test whether inserting an obstacle at a location causes a loop. So I'm going to leave this bottom slot. I'm going to say new obs will be a point of 2, 1. Now I want, I need the lab. So guarded lab from str input dot unwrap unwarp. I do that a lot, and I want to assert that lab dot causes loop. I don't even need the current guard's position because I can always do it from the start point. So I will just give it a new obs, and I think it will take a reference. And that's it. Okay, lab causes loop doesn't exist, so let's define it. Function causes loop and self and obstacle, which is a point. and I need it to return a bool. Okay. Make it return false. Good. So I will have a traveled and I will have a guard, but I'm going to save it being a facing point. Now I'm going to do the traversal logic. And at some point, I work out the new guard position or the new guard facing point, and this is where I can say if traveled dot contains traveled is, yeah, it's a hash set. So can I just do brackets? Guard dot is sum. How do I look up from a hash set? Clone from, trying to borrow Rust hash set contains books.insert books.contains. So why is it not giving me contains as an option? Guard. Return true. Travel.insert guard.pause. Trait bounds is not satisfied because facing point needs to be hashable. That's why it wasn't auto-completing it. So I can just give it hash. And then direction doesn't have hash, so I need to make sure that direction has hash. Hash. And that's now satisfied. But this is not. Yep, because we need to insert guard. And we borrow here. Okay, that is fine. I'm doing something where I'm not inserting obstacle into obstacles. I'm just doing a separate check for it, which means that I don't need to mutate the object underneath. So I can now do or obstacle is equal to next pos, which I'm not allowed to do. Can I dereference obstacle to do that? I can. That should work. Part B obviously doesn't give me anything yet, so cargo test. Oh, infinite loop. Glorious. Doing something wrong. Okay. Traveled is hash set new. Guard is guard.start. We check if guard is within bounds. We insert guard, which is a facing point, so that should be fine. This Does what I've done actually create a loop? That's an interesting question. I guess it's because I don't travel at all. That should still work though. Maybe I guess I can repeat the check here. That passes. Okay, so I was spinning the guard in a circle, but because I never checked traveled within this and just kept continuing, it just kept circling around here. So that's right, but does it work for the real thing? So let's test text part A. I'm going to copy that. Part B. Part B. And it will be 6. Okay, this should fail because we've not written part B yet. There it is. So now I can define part B. So part B is pretty simple. I'm going to iterate over all possible positions that aren't already an obstacle. And I'm going to try and insert it and see if it causes a loop. So for row index in self dot height, but it will be a range. For col index in 0 to self dot width. Test obs is a point containing the row index and the col index. If self.obstacles.contains test obs already, oh, I need to do a let. Then continue. Otherwise, if self.causes loop and test obs, add one to the accumulator. Then we return count. This is not allowed because this needs to be an I32 and an I32, or 23 apparently. And that should be it. Cargo test. Result okay. So at this point, we should be able to get a new line, part B, cargo test and cargo run. And apparently that takes some time to work out. I don't know if this has gotten into an infinite loop or not. So input is a very large grid. I think it will eventually finish the calculation, but advent of code isn't intended to take a long time to run. Usually if it's taking a long time to run, that means that there's a better way to do it. You can normally collapse it down to within a few seconds at most, in my experience. So there's probably a better way to calculate this. Perhaps what you do is, over time, figure out whether the other option is that I did just create an infinite loop. So I'm going to test that by just print lining the test obs as I go. Test obstacle. By doing that, I can check that the numbers are still going up. 2, 3, 4, 5. Yeah, so it's just taking a lot of time because there's 131 rows. So this would eventually finish. I'm not happy that it's taking so long. I'm sure there's a better way to do this. Okay, so one possibility is that you only test obstacles which are in the path of the guard. So you do one run, which gets all the possibilities of the normal path, then you only test inserting obstacles into the points along that path. That seems like a good thing to do. So let's start by function get guard path and self, which will return a hash set of points. It's actually getting pretty close to maxing out, so we will get the answer in a moment, but there's a better way to do it. I'll briefly try and do it. If I take too much time, I'm over time already. If I take too much time, I'll stop and leave this as an exercise for tomorrow, because I think this will complete it, but I would like to do it in a shorter amount of time. There it goes, 1,304 apparently. Let's try it. Well, at least we got the right answer. So we have solved day 6, just not to my satisfaction. So let's try doing it. So part A, I can just copy and paste this and return traveled. And then I don't need it to be mutable. I just need self dot equals self dot get path. And then I do return travel dot length. That's that. And then part B will be let traveled equals self dot get guard path. Then for pos in traveled, mute count goes up. Now I can't run this with my tests. Actually, I can run this with my tests because I'm inserting a new obstacle. So yeah, that should work fine. For pos in traveled, it can't be in the obstacles list. So we literally just increment the count. That's it. Ooh, it's not happy with this because it should be pos. Try that. It's still taking some time to compute. So let's try inserting that with pos. It did finish, and it finished much faster. I still think that there's a way to optimize this further, but considering it works within a few seconds, I think that's fine. I'm happy with that for a day 6 solution. I'm sure it can be done better. Please tell me in the comments if there's any hints that you've got to help speed it up. I'm happy with you just telling me a better way to do it if you prefer, because I'm unlikely to return to this. I'm just going to continue with the other Advent of Code challenges. One quick thing is that I can run it in release mode, which probably will make it extremely quick. Especially if I remove this line. So at that point, it only takes 3-ish seconds. I still think it could be done faster. These challenges are meant to be done in a few seconds, even in interpreted languages like Python. Just because I can compile Rust in release mode and get more performance out of it, doesn't mean that I'm doing it right. Anyway, that's enough for day 6, and I'll see you tomorrow for day 7. Thanks for watching.